Do you love segregating your network into as many subnets and VLANs as possible? Do you have too many Wi-Fi networks for all those special IoT device cases or cameras or whatever else that you don't want to put on your main network? You also don't want to let fend for themselves on the internet because they barely speak IP? You could use WPA EAP or Enterprise Authentication, but good luck getting your smart toaster to log in like that. The solution I'm playing with is called private pre-shared keys, where each client thinks it's logging into a normal WPA2 network, but in reality, on the back end, it's being assigned a separate passphrase and a separate VLAN, potentially, for every single client. This means we just need one single SSID for a whole network, and all of our devices can get divided up into their VLANs on the back end automatically just by their MAC address. So for this video, I'm using a Mikrotik WAP AC running RouterOS 7.8. And this video is fairly RouterOS specific. I did try to do this in OpenWRT first, but the code is just not quite there yet on their end. Some of the patches are still being merged in to support this. So Mikrotik it is. I haven't tried it on the new Wi-Fi Wave 2 either, because I don't have any Wi-Fi Wave 2 devices. If you'd like to send me one, I can definitely test it. But yeah, come along, let's get started. So I start off by resetting the configuration here. So we're going to go up how to set up a real basic wireless access point on the WAP in RouterOS. So let's pull up Winbox. So over here in Winbox, I already found it. So RBWAPG, that's the model we're going to connect by MAC address, and it has no password because it was just reset. And of course we need to change that. So we could give it a name to, how about access point. And we need a bridge so we can connect our Wi-Fi directly to our LAN. And we're just going to call that bridge. And we're going to enable VLAN filtering. There we go. On the bridge ports, I'm going to add Ether 1. And the WLAN interfaces, they're currently disabled, so they show up in italics. So now everyone's on the bridge. And finally, we need to give our guy an address. So we'll do the normal pool. You can just click EUI 64 and it'll fill in the rest for you. There we go. And wireless. So as you can see, we have two radios in this particular model, the 2 GHz and 5 GHz. So same configuration for both. I'm just going to enable the 5 GHz for this test. So you want to be in AP bridge mode. You can set the SSID whatever you want. And security profile default. So this is a default security profile that exists. And we can have more than one security profile if we want. I'll show you what that means in a sec. WPS should be disabled. There we go. So security profiles are basically a set of authentication parameters for a network. And you would create more than one of these if you want to have more than one SSID with separate authentication types. And you would create less than the number of radios you have because you might share these profiles between your 2.4 GHz and your 5 GHz radios. So let's name default. Our mode is going to be dynamic keys. So that's how we get WPA2, PSK, and our pre-shared key. So we'll just name that pre-shared key, and off we go. So let's see if we can find that network on a laptop. Here in the laptop, we got Bill Y, the Science Fi. And boom, we're in. Sure enough, we got a bunch of IP addresses, so it looks like that worked. So now that we have the most basic Wi-Fi setup, let's add some radius to this. Let's get FreeRADIUS installed. So in order to keep track of who should be allowed to log in when, we're going to use a system called Radius. And this is really commonly used for 802 authentication, so you use it a lot for 802.1x, port-based authentication and switches and things like that, and also for Wi-Fi. So I'm going to create a Linux container for this. You're free to do a virtual machine. I'm going to call this guy, I'm going to start from Debian 11 standard because that's just a great base to start from when you're running your own container. Again, don't need much space or memory or anything. So I'm picking an IP address. this case, I'm going to pick an address that's easy to remember. So for the access point, I just picked a random number because it's fine. There we go, creating that container. So let's start this up and install FreeRADIUS. So on every new system, we like to do an update and upgrade just to make sure all the latest packages are installed. So apt update and apt upgrade yes. And now we can install FreeRADIUS, and it's literally just one command. Apt install FreeRADIUS, yes. Takes a little bit of time, you know. So it gets started by default. I'm going to stop it for now just to show you some features. So you can run FreeRADIUS-X, big X, if you want to debug. But you need to make sure the system service is stopped first. Then you can launch the executable manually through the command line, and it'll run on the command line and see the output. If you're trying to debug your requests and something's just not working, run it this way. When you run it this way, this will give you a lot of debug information, and you can see where you're going wrong. You'll see all the steps the code is progressing through, why it's accepting or rejecting the client, all the metadata that goes with that. Use this mode. So now let's add the server to Mikrotik. Over on Mikrotik, we click the Radius button. We add a new server. It's allowed to be used for wireless, and we put in the address. And we need a secret here. So Radius is not the most secure protocol, and the secret is basically the way that the client and the server authenticate each other. So in this case, the client is the access point, the server is the Radius server. So you need something in here that's going to be mutually known to both sides. If you click on the status screen at the top, it'll show you what's going on. Currently nothing's working. Remember how I said we got to put that key on both sides? Let's put that in FreeRADIUS now. So let's edit etc FreeRADIUS 3.0 clients.conf. And we're just going to go all the way down to the bottom, and we'll add a new section. So we give it a name, management net, and some little squiggly brackets. So now we need to say the IP address that this client is allowed to connect from. And you can either just put in the address as it is, or you can put in a CIDR notation subnet mask. So if you put in something like this, then any client from that subnet will be able to connect. And secret. And we'll save that. And restart FreeRADIUS. And no errors, so it came back up. We go back to the Mikrotik side. Looks like it's done an accept already. That's good. So at this point, we have a working Radius server. The Mikrotik access point knows about the Radius server, but the Wi-Fi network isn't configured to require Radius authentication. So let's turn that on. So under the security profiles here, we're going to open our security profile and click Radius. We're going to say we want MAC authentication. What this is going to do is it's going to use the MAC address of the client when it connects to the access point as the username. That means our Radius server needs to be configured to look for an address in one of these formats. The default is with colons in uppercase letters. The MAC mode is as username, which means the username will be filled in with MAC address. And the caller ID format can either be MAC, MAC and SSID, or SSID. And in my case, since the username is already the MAC address, I set this to SSID. So called ID format can be used if you have more than one SSID using the same Radius server to separate which SSID the client is trying to connect to. MAC caching time, this lets the access point save authentication requests over time. Usually you'd want to set this to a relatively high number, like an hour or a few hours. For testing purposes, I'm going to leave it disabled so I can tweak things quickly. So going back over to the Radius server, I am running it again in debug mode. So what happens when I try to connect with the client? So we click on Bill Y of the Science Phi. I type in the correct password. It is correct. And over here we see it's trying several times, and eventually it'll probably give up. Yeah, so it looks like it tried 3 or 4 times. So if we look at the information we got from it, so we got a request in. The username was 183EFD1C461. And the call to station ID, that's our SSID, that's Bill Y the Science Phi. A NAS identifier is WAP, that's the host name of the access point. In Mikrotik, you set it under system identity. NAS address, that's the address of the access point. And you can see the section we went through in the authorized file. And eventually it determined that the user is not authorized. So it did a reject. And then the user tried a couple more times and eventually gave up. So we didn't add anything at all to the radio server telling it that this specific laptop is allowed to connect. So it just denied them by default. So let's start by adding an allow all, just so people can connect as they usually would. And we're only modifying things that are unique. So we got to stop the server and edit a file. Let's see, FreeRADIUS 3.0 mods config files authorize. It's a long one. This file is processed in order from top to bottom. So all the rules we add, we need to be aware of the order. So unlike most config files where you just go to the bottom and add your stuff, we're going to add our stuff at the top, and we're going to be very aware of the order. So I'm going to add a line here that says accept clients by default with no other information. So default is a special word. Normally we start lines in this file with the username, so we would start with something like that. But default is a special word, so we're going to say default auth type accept. And we'll save that, run FreeRADIUS again, come back over here. Let's try Bill Y the Science Phi. Over on this side it says sent access accept. And we are connected. So now we know how to let people log in like they used to. This is where it gets fun from here, all the fun stuff we can do with Radius. So now that we understand how Radius works very, very, very briefly, let's add some fancy rules to configure how this MAC connects to the network. We're going to become good friends with the authorized file, so let's jump back into the authorized file. So remember how I said that the first word on the line is the username? So in our case, the username is the MAC address. So Mikrotik formats the MAC address as the username is the MAC address in all capital letters. So we use capital letters in our hexadecimal. So the first line is deciding if the client should match this rule. So in this case, it's the username, and we're also forcing the auth type to be accept. After that, we have arguments that we return back to the access point. So a couple ones we can play with are Mikrotik. So Mikrotik wireless PSK. This will override the password for this specific user. So I set that to super secret. Run in debug mode again. Go back over on the laptop. So I try to connect to Bill Y the Science Phi, and we got accepted, but we're not able to connect. And the problem here is that our password is wrong. So let's forget that network. So you forgot that network. Come back in. The password for this specific client should be super secret. There we go. We can see in the log here, Mikrotik wireless PSK is super secret, and user is able to connect. So if you have any special devices on your network, you don't trust them to not leak your key, you think they're going to ship it off to China or whatever, give them their very own key, only works for them and nobody else. And that's really all well and good, but what if we not only want to give this person their own key, we want to put them on their own network. So we just want to have one SSID and everyone connects to it, and if we have a special use case, we can put them on another network. So by default, everyone's on the guest network or the open network, and if we choose to put them on the IoT network or our internal server network or whatever, we can take their MAC address, add to the authorized file, give them special VLANs. So back into our friend the authorized file. Mikrotik wireless VLAN ID. Does just like it says. Now, because we have more than one argument here, we've put a comma after the first one, but not after the second one. It's picky. And we'll save that file and start it up again. So back on the Mikrotik side, we have bridge VLAN filtering enabled. So we need to add ID 9, tagged on Ether 1, and tagged on the WLAN interfaces. Now it should work. So we connect to Bill Y the Science Phi. And sure enough, we are on a network. But we're not on the same network, we're in VLAN 9. So if you want to put your IoT gadgets, your cameras, whatever, on a separate VLAN, without giving them their own SSID, put them in the authorized file, their MAC address, special VLAN, special password if you want, great. Now what if you don't want to have to edit this rule for every one of your cameras? Well, if all of your cameras happen to have the same vendor, you can just put the MAC OUI in. So MAC address is 6 octets, so that's 48 bits, and the first 3 bits, the first 3 octets, are always assigned to the vendor ID. And if you know the vendor ID of your cameras or your IoT devices or whatever, you can put those in the authorized file and not the whole MAC address. Let's do that. So I'm going to start with default because I'm going to filter. I'm not typing a literal username. Then I'm going to add a username equals tilde. And equals tilde means matches regular expression. So it's going to parse a regular expression from the username field and check if it's true or not, so if it should match this line. And in this case, we're going to check caret, which means start of the string, and then 183EEF. So it's going to look for a MAC address or a username that starts with 183EEF. So if all of your smart plugs or cameras or whatever are all from the same vendor, there's a really good chance they'll have the same OUI and the first 3 digits of the MAC address. You can put that in here instead of having to type it out for each one. Then we're going to put a comma because we got more rules, and we're going to say auth type accept. And then for parameters, we're going to do the PSK and VLAN ID again. So click on Bill Y the Science Phi, comes over here. Again, it found it super secret 9. And we're able to connect. So now we've just put all of our smart devices from the same manufacturer on their own VLAN ID. They don't even know it's different. Same SSID, different password if you want, different VLAN ID, magic. So now we've figured out what happens if the OUI is known, but what if we want to filter on devices which are using privacy MAC extensions? They might mess with our MAC address rules. Let's deal with that. Once again, back to our friend, the authorized file. So what if we want to catch all mobile devices? These are devices that are using privacy MAC extensions. They're randomizing their MAC address. We want to catch them in a separate rule. Maybe give them a separate VLAN, whatever you want to do. We're going to use a regular expression again. So we're going to start with default. So this time, match the beginning of the string. Then we're going to look for one character that's either a digit or A through F. So it's a hexadecimal character in capital letters. Then we're going to look for another letter that is either 2, 6, A, or E. So 2, 6, A, E. So this will match if the second digit, or the least significant digit, of the first octet of the MAC address ends with a 1, 0. That means that the MAC address is a unicast address, not multicast, and it is locally assigned. So globally assigned addresses have an OUI in the first 3 octets. Locally assigned ones can otherwise be entirely random. So privacy MAC addresses will be locally assigned, and they're going to end with a 2, 6, A, or E. And then we can end, because we're just looking at the first 2 digits of the MAC address, the first octet, and we're going to accept in this case. So we don't have to give them a VLAN. We could give them a VLAN if we want. Ooh, server be angry. Oh, forgot a comma. It's real picky about formatting. There we go. And what if I try to log in on my phone? My phone's going to use privacy extensions. Not gonna screen cap my phone, but just trust me on this one. Bill Y the Science Phi. It's like we hit this rule. It says line 2. It'll tell you what line number you hit, by the way, too. So you can do better debugging of your authorized file. So my phone was able to connect. My phone did not get assigned to VLAN. The laptop was able to connect. It did get assigned to VLAN. Neither one of them hit the default rule. So my phone is using a privacy address. My laptop's not. Cool. So what if we have more than one SSID? I know, the whole point of this video is to not have more than one SSID. But what if we do, conceptually? How do we put that in the authorized file? Just for the sake of this video, I'm going to change the name of my 2.4 gigahertz LAN from Bill Y the Science Phi to Space Lasers. So I got Space Lasers on 2.4 gigahertz. I got Bill Y the Science Phi, 5 gigahertz. Both of them are using the same security profile, which means they're using MAC-based authentication. So now back in the authorized file, say we want to authorize this guy, but we only want to authorize these on our 2.4 gigahertz. We want to force them to 2.4 or we'll force them to 5 or whatever. Reject them, I don't know, whatever you want to do. So we're going to use called station ID. So in this case, we're only going to let this client in if they're connected to space lasers, but not if they're connected to Bill Y the Science Fi. You can add these rules onto any one of your things in the authorized file. I'm just using this one as an example. Start the server back up again. So we got a request, and we got accepted, but we got accepted by the default rule, I believe. So what if I want to log into space lasers? So now I got a different reply. Now I got the PSK and the VLAN ID because I logged in to the different Wi-Fi. I mean, you can filter on any of these parameters. If you want to let them only connect to certain Wi-Fi networks or only connect to certain access points, you can filter on NAS identifier. So in this case, for Mikrotik, NAS port ID is the name of the WLAN info, so it's WLAN 1 or WLAN 2. NAS identifier is the host name of the Mikrotik device. I have it set so called station ID is just the SSID, but you can also have the MAC address base station, the BSSID if you want. It's just tons and tons of flexibility here in what you can make the access point do. And from the point of view of all of these users on Wi-Fi, it's just like a regular Wi-Fi network with a normal password. They don't know they're being assigned to different VLANs in the background. It just works. It's great. So one last feature we could potentially be missing, depending on how you want to configure your network, is forwarding. So on some Wi-Fi systems, this little check mark that says like guest Wi-Fi. And basically what it means is that clients on the network aren't allowed to talk to each other. They can only talk to the router. So in Mikrotik here, go to our wireless, there's a checkbox that says default forward, and Mikrotik calls this forwarding. So when we disable default forward, that means clients cannot forward between each other by default. Obviously when we check the box, that's the normal Wi-Fi. And we could just uncheck that, but we can actually put that in our authorized file as well. So we go to our friend, the authorized file, and go down here to the default accept. We can use a tag called Mikrotik wireless forward. So this means is that if you hit one of these rules up here, forwarding is allowed because forwarding is allowed by default. But if you fall down to this forwarding rule, then you can't talk to anyone else. You can just talk to the router, not between clients. So this is part of my series trying to rebuild my home network from the ground up to be optimal. So I'm looking at using a technique like this for consolidating my Wi-Fi networks, allowing me to segment things without having to create a whole bunch of SSIDs. And I think this is a pretty good solution. I'm pretty happy with it so far. I could probably do a little bit better on GUI configuration of FreeRADIUS. I know there's GUIs out there. The authorized file isn't that hard to work with, really. At least I don't think so. But yeah, that's an option. I'm using Mikrotik hardware for now. I do like their hardware a lot, especially RouterOS. RouterOS is awesome. I do wish they had some more modern radios, but not a big deal. The WPA AC that I'm using works great. I'm happy with it. I did try OpenWRT on a Raspberry Pi 4 and I could not get it to work. It seems like host APD does support private pre-shared keys and RADIUS authentication for PSK clients, but some of the configuration generation required to get that into OpenWRT is not quite there yet. Some of it's been merged and is in snapshots only. Some of it is still being code reviewed, so it's not quite ready yet. Maybe I'll try to OpenWRT later, but for now, Mikrotik it is. As always, if you have any comments on my home network, I love to hear about them. Other things you like doing. I know a lot of other vendors do things similar to this. It's not just Mikrotik. And it should work similarly on their end. I don't know obviously exactly how it works, but this is my setup with Mikrotik. If you want to chat with me more, comment section's open. Discord is open, link down below for that. And as always, I'll see you guys on the next adventure.